Hi,
Hello,
my name is Ling Wu.
and my name is Jesse Refson.
Today, Jesse and I are going to walk you through our solution, ResearchExplorer. VCs invest in early-stage scientific research for a chance at high returns and first-to-market advantage. But evaluating that research is difficult. VCs may not have the expertise to evaluate its rigor or relevance. External human advisors can add bias, costs, and delays. And what's more, the early stage research data is often pre-publication, unstructured, and highly technical. In other words, a data overload. And because the work is not yet public, using open tools or public AI services risks leaking sensitive data, which could compromise IP or competitive positioning. VCs need tools that will let them securely, quickly, and clearly evaluate complex science. Our solution, ResearchExplorer, helps VCs quickly evaluate early-stage biomedical research using AI-powered analysis, which is securely hosted on private servers to protect sensitive data. So finally, VCs can cut through the noise, identify real scientific potential with speed and confidence. How does it work on the back end? The user submits a text query through the UI, which is passed to an embedding model. In our case, we use PubMed BERT, which is optimized for semantic search in biomedical research. The query is then transformed into vector representation, then used to search across two sources. One is in the IRIS database, which serves as the VC's internal research and diligence database, and also the RAG vector database. And it will search to an external database such as PubMed for biomedical research repository. Search results from both sources are returned and passed on to the LLM. In our case, we use GPT-4o, which processes, interprets, and analyzes the data using engineered prompts. The final interpreted response is then returned to the UI for the user to view, which is clear, structured, and ready to support decision-making for the VC. For a VC analyst user, the workflow begins with the analyst identifying a seed abstract of interest from the VC's private database. The solution then retrieves data from the selected research. At this stage, the analyst has two options. The analyst can either ask targeted questions about the seed research, or it can use a public repository such as PubMed to fetch 3 similar high-impact studies. Next, the solution generates a tabular comparison of the 4 papers. This allows the analyst, as the human in the loop, to refine and validate the comparisons, ensuring all row labels and metrics are aligned for effective evaluation. The user can then dive deeper by asking in-depth questions about the seed paper with extra context. Or the AI can be further prompted to generate additional questions for researchers. Once the due diligence process is complete, the user can generate a PDF summary report to share the findings.
Alrighty, well, let me go ahead and take you through a demo of everything that Lynn just talked about. So here we have the actual front end of our tool. And we're going to start off, I'm inhabiting the role of the VC in this case. I'm going to start off by asking for what are the top 10 papers that are currently available in our private database that I may want to explore further. So I can ask, show me the top 10 studies in our database for further exploration. And it's going to go out, it's going to go to our private database and return those top 10 papers that it thinks warrants further exploration. So I can look through these and I can read the little abstract to see just basic summaries of the papers and the work that's being done. And as I go through these, maybe I see that there's one on wearables that I'm especially interested in. I've read the abstract and I think it looks good for the work I'm trying to accomplish. So I'm going to go ahead and click on the Explore button to see this study in more detail. It's going to go out and it's going to fetch the entire PDF of the study, which I could then scroll through, read, and actually get the information from it. However, recall that in the role I'm in, I'm a VC that has sort of general scientific knowledge, but not really like deep expertise in this area. So I don't really have the requisite expertise to fully digest the data in this study. For this, I'm going to need the tool to use AI to help me assist in my understanding. First thing I'm going to do to that end, as Lynn called out earlier, is I'm going to compare this study against the top 3 publicly available similar studies. The reason we do this is because publicly available studies have already been digested by the scientific public. They've determined how reputable these results are, how well conducted they are, and how much you can rely on this data. By taking this private study and comparing against publicly available studies, I can start to get an idea of just how high quality the data is in my particular study. So I'm going to go ahead and click on this compare button up at the top. And it's going to go out to that public database. It's going to grab those top 3 studies that are most similar to my original paper. And you can see here, I've still got that original seed paper on the left, but now I've got 3 additional papers as well, 3 comparison papers that are similar in scope to the paper I'm looking at. If I were to click on one of these papers, I could actually read through the whole thing once again, go through the whole study. Or what I could do is I could look at high-level comparison of the different sections in the paper. So if I wanted to see the introductions compared, for instance, I can click on this introductions dropdown where I would be able to see my seed paper's introduction, but also the introductions of those 3 other comparison papers as well. And this would be the same for results, methods, and conclusions. I could also now, with the context of these papers, I could ask questions out to the LLM. And this is that RAG pipeline that Lynn was talking about earlier. If I ask a question, it gets vectorized. I can see semantically which papers or which parts of the papers rather are relevant to my query in the comparison papers and the seed paper. And then that whole block of vectorization, the query, the paper's context goes out to the LLM, at which point the LLM can answer the question with the appropriate context of the private and public data intermingled there. So for instance, if I want to know, compare the sensitivity between the seed paper and the comparison papers, I can ask this. This will go out to GPT-4o, and it's going to return a result that is using the LLM as well as the context from the papers I passed it to answer this question. So I'm getting much more in depth into the science and the data without needing domain expertise. Finally, if I wanted to generate a report of everything that's been going on and pass this along to my colleagues, I could click on this Generate Report button at the bottom, which generates this PDF. And then I can use this PDF to pass this information along to my colleagues to then proceed forward in my actual goal, which is to explore the data, see what possible business opportunities there may be here for further monetization. All right, so that's a look at the demo of the tool itself. Let me jump us back into our presentation slide deck. Just want to call out a couple more things before we finish up today. First off, we've seen the tool. What's so special about connecting this tool over to IRIS, to our InterSystems technologies? Why is that appropriate? Well, we really feel that this slide does a good job of encapsulating what InterSystems excels at and why this would be appropriate for connecting to a tool like this. I think first and foremost, security is top of mind here. This data is potentially very valuable depending on how it gets monetized. Sticking it in a public database would not be appropriate, or even an unsecured database would not be appropriate, because if that data gets out, you can't really put that genie back in the bottle, and that could be a potentially very costly loss. So the security of InterSystems technology is really important here, as well as the reliability, because if you can't get at the data when you want it and when you need it, then of course the tool doesn't work at all. We're also known for our innovation and our ease of use. I think it's especially appropriate in this case, given that we're talking about some cutting edge technology using LLMs and AI. And then finally, interoperability, which is, of course, our bread and butter. The data you see in a study like this can come in a number of different structured formats, and being able to interoperate between those formats is very important. And then lastly, just to call out a few takeaways here, we've seen today how even in a situation where you've got a diversity of data that might be hard to interpret for a human who lacks potentially the research domain knowledge, we can help to alleviate that dilemma by connecting that data over to an LLM. We can also provide objectivity where a human might have some subjective interpretation of the data, and also help to make the data less confusing, especially if it's uncurated data that's not presented in a study. Also want to call out the importance of security once more, because we really do see that as a top concern in this type of issue, where you've got a lot of sensitive data that cannot be leaked out, otherwise it loses its value. The benefit of using a tool like this is you have faster time to value, faster diligence, so that a VC can look through this data, can look through these studies, and make determinations about which avenues they want to go down. They can make really informed comparisons using the expertise present in other studies to compare it to their current study, and then run that all through an LLM to get these comparisons and benefit from the security of it all along the way. Alrighty, and that's what we have for you today. We really appreciate you all taking the time to look through and watch our demo.
Thank you.